minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff, Starlink 47.
Vehicle is pitching downrange.
M1D chamber pressures are nominal.
We are T plus 40 seconds into liftoff. Falcon 9 has successfully cleared pad 39A and carrying our stack of 49 Starlink satellites into orbit. Moments ago, we began to throttle down the engines on the first stage in preparation for max Q. This is where the vehicle will experience the highest amount of aerodynamic stresses during ascent.
Max Q.
And there was max Q. We are getting some great views of this daytime liftoff. In about a minute, we have 3 events happening in quick succession. First up is main engine cutoff, also known as MECO, followed by stage separation, and then second engine start 1, also known as SES1. During main engine cutoff, this is where all 9 Merlin engines on the first stage will shut down in order to slow the vehicle down in preparation for stage separation.
MVAC engine chill is started.
During stage separation, the first and second stages will separate from one another. The first stage will make its way back to our drone ship in the Atlantic Ocean for its landing attempt. And the second stage will continue with the third event, which is second engine start 1. This is where the single Merlin vacuum engine on the second stage will ignite and continue to propel the second stage along with the 49 Starlink satellites into orbit. Those 3 events should be happening here in about 20 seconds.
MECO.
Stage separation confirmed.
MVAC start.
Fairing separation confirmed.
So we've had successful main engine cutoff, successful stage separation, successful second engine start on the second stage, and then also fairing deploy. On screen right now, you can see the first stage booster at the bottom of your screen making its way back along with the 2 fairing halves. They've deployed. They were at the top of the screen, but they'll make their way back towards Earth and be recovered by our recovery vessel, Doug. As a reminder, those fairing halves, one was flying for the 4th time, and the other was flying for its 6th time. So a couple of views on screen right now. On the right-hand side of your screen is a view of our single Merlin vacuum engine on the second stage. Those Starlink satellites that we have been talking about, all webcasts, those are located on the opposite end of that engine. On the left-hand side of your screen is a view from the top of our first stage looking down. Its job right now is to head back towards the drone ship, a Shortfall of Gravitas, and make its 6th landing attempt. In order to make its way back, the first stage has 2 burns today.
Both vehicles are on nominal trajectories.
The first is the entry burn, where 3 of the Merlin engines will reignite, and this helps to slow the stage down as it re-enters the upper parts of the Earth's atmosphere. The second burn is the landing burn. This is a single engine burn that will bring the vehicle speed down rapidly in order to land on our drone ship. The first burn is expected to start around the T plus 6 minute and 47 second mark, and the second burn is going to be starting at the T plus 8 minute and 26 second. So we are still a few minutes away from the next milestone. The Starlink satellites that we're going to be delivering today, we're going to be delivering them to low Earth orbit, and they'll be operating at about 550 kilometers. Most satellites are at 36,000 kilometers in altitude in geostationary orbit. And when satellites are farther from Earth, the round-trip data time between the user and satellite, known as latency, is much higher, resulting in poor performance for activities such as video calls and online gaming. Starlink satellites operate at over 60 times closer to the Earth than traditional satellites, resulting in much lower latency. It's continuing to go well for both stages. On the left-hand side of the screen, we see some action. Those puffs of gas, that is nitrogen from our attitude control system. That, in conjunction with the grid fins that you see on screen, those help to steer and orient the first stage as it makes its way back to its targeted landing zone. So we are about 20 seconds away from the first of 2 burns on the first stage. 3 engines on the Merlin, 3 Merlin engines on the first stage will reignite and help to slow down that stage before it hits the denser parts of the Earth's atmosphere.
Stage 1 FTS is saved.
Stage 1, entry burn startup.
And there are those 3 engines that have reignited. This burn is expected to last for about 20 seconds.
Stage 1, entry burn shutdown.
Awesome. That is 1 of 2 burns successfully completed.
Stage 2 FTS is saved.
In about a minute, we have a couple events happening in rapid succession. So we'll have the landing burn start on the first stage, and then as that is ending, and as our first stage is going to be attempting its 6th landing on our drone ship, we are expecting second engine cutoff on the engine that you see on the right-hand side of your screen, followed by the call out for successful orbital insertion. And as a reminder, because we won't have ground station coverage during the time that the Starlink satellites separate today, we will be ending our webcast
Stage
after
1,
we confirm orbit of the second stage, and then we'll confirm deployment on our social media platforms. Just under 10 seconds away from the landing burn of the first stage. For now, we are enjoying some
Stage 2 is in terminal
great views of the second
Stage 1
stage
landing
Merlin
burn.
vacuum engine. So you can see that the drone ship is getting closer, and on the right-hand side of the screen is that drone ship, a Shortfall of Gravitas.
Stage 1, leg deploy.
Does look like the video cut out for a little bit. And hearing some cheers here in Hawthorne. And there's visual confirmation that the first stage has landed for the 6th time. And this marks our 106th overall successful recovery of an orbital class rocket. That includes both Falcon 9 and Heavy first stage landings.
Good orbit insertion.
So during that time, we also got a successful second engine cutoff of the second stage, and you just heard the call out for good orbital insertion.